All right. Happy Friday, everybody. I'm Bonnie. This is Tech Stack Nation. I am very excited about our topic tonight and our guests. We're talking about the new signals for JavaScript proposal. We're supposed to have Dan Ehrenberg. He's sick today, unfortunately, but we've also got Ben Lesh and Alex Rickabuagh, and they're amazing. They're so much fun. We're going to have so much fun today. Let's start out with Ben Lesh, our lovely, our very favorite problem child, Ben. I just love having you. How are you?
Am I a problem child? Is it that bad?
Yes, but in a good way. You always make me laugh. Your hot takes are something else.
Well, thank you. I'm happy to be here. I've already said this to you, but I'll say it to anybody else that's listening. I am currently today doing a RxJS workshop to benefit the Zach DeRose family, who had a house fire and tragically lost one of their children. So I have to get back to those people at about halfway through the hour. So,
all right. Well, we'll just get right started then.
All right.
And then so you got dragged into this initiative very early on, and then you dragged in Alex Rickabuagh.
Well, I was more like, you should definitely bring Alex Rickabuagh in, because Angular has a signals implementation. It's basically the same thing that we're talking about here. Observables are not at all the same thing. I mean, they're reactivity. But other than that, they're very, very different. They've got different use cases, that sort of thing. So I'm excited to do this. I'm excited to do this with Alex. There's the Angular community is a lovely community, and I'm just going to jump right on it. I'm going to say Alex, and I know this is not Alex's choice, but the Angular comms around this, where they're like, new reactivity. I was like, oh God, no. Because as soon as I saw that, I'm like, they're right. But you give this word reactivity to the masses, and they're like, oh, this replaces RxJS. And it's like, no.
There has been a lot of confusion about that. Like, we don't need RxJS anymore now that we have signals, but that's not exactly true.
Right. Yeah, the challenge there is
debouncing signals and stuff, and you're like, oh, stop. Don't do that. Yeah.
From a framework perspective, right? The term reactivity is kind of a term of art. It has a very specific meaning, which is how the UI stays synchronized with the model. So when we talk about reactivity system, we're kind of talking about that, and less about the like, how do I fetch data and debounce things and like drive the kind of big wheels that are feeding the new data into the UI.
Ben, can I share this screenshot from our friend Tracy Lee? Remember I showed this to you?
Sure, yeah.
I love this this slide. This was from a presentation that she did, and I just really love how well she explained this. I think both of you you probably helped with this. Can you just talk us through the slide? Because this is like the best explanation that I've seen of the difference. Can you just talk us through this?
Yeah, this is an explanation that came from me when I was working with her on her talk. That's why I'm sure that's why she put my picture at the bottom. But yeah, the biggest difference between observables and signals is observables, like, despite signals having a much simpler API, they're much more advanced as a type in what they're actually doing, where observables are much more simple as a type in what they're actually doing, which is one of the reasons why the API surface area is so big. So observables are generally stateless, just like a function is generally stateless unless you close over it, close over some value or something. Observables give you multiple values, so 0 to n values over time. And then when it comes to like observables and signals, especially in like Angular, where there's a lot of observables like floating around that people are using, you might want to convert an observable to a signal, but it's pretty rare that you'd want to do it the other way around. And the reason for that is observables represent events. Like they're something that happened or is currently happening, and you can treat them as sets, so you can do interesting things with them, and you can cancel them, and you can switch map and all these lovely things. The biggest thing is, though, they're a set of events. They're generally stateless. They've got some teardown guarantees, and they're cancelable. So like dealing with events, observables all day. You don't want to use signals to deal with events. And the reason for that is, if you look at the other side, they maintain state and they're for a single value, right? And so you don't need to maintain state on mouse move events, right? That doesn't make any sense. Like, you don't want to be like, oh, here's my signal of mouse moves, or here's my signal of text inputs. That state technically already exists in the input, whatever. But like, it'd be weird to make events signals, and kind of inefficient because signals maintain state. They also have this idea of like a dependency graph. So like, if you say, here's a signal and here's a computed signal, a computed signal, a computed signal, and like it has to, when you read from it or when it notifies, it has to basically crawl this graph and be like, what's changed? Have I changed? Do I need to recalculate, and all this other stuff? So there's logic and things that need to be executed and things that need to be kept in memory and whatever related to all of that. That's what I mean when they're a little bit more advanced type. So it's not usual that you would want to be like, oh, here's some value that I want to render to the page. I'm going to make it into an observable. That's kind of strange, because anywhere that you would set that value or set something that updates that value, you could just next into an observable or fire a method or whatever that had some observables. So it's kind of a more weird. You might want to do it in some cases, but it's strange that anyone would want that.
Alex wanted to add something.
Yeah, no, I'd love this slide too for exactly those reasons. I think I saw this and I was like, okay, yeah, that actually is really capturing the difference particularly well. Just to reiterate kind of the point that Ben's making for why you might not want to convert signals into observables. What signals give you, because they're trying to track the state of your application. They're trying to track the state of kind of all of the signals in the system being the thing that determines your UI. They give you a guarantee that when you read them at a specific point, the entire graph will be consistent. They do not give you a guarantee that you can keep track of every value that signal has as it changes over time. So if you set a signal to 4 different values in a row, all the graph cares about is at the end of all of that, when the UI is rendering, it sees consistent data across the graph. It does not ever give you the guarantee that you observe the intermediate values, which is exactly what you want for events, because it doesn't make sense to drop a click event on the floor. If the user clicked the button, you kind of want to know about it. You don't want to say like, well, you know, they clicked the button a millisecond ago, but the button's not being clicked right now, so who cares? That's kind of the fundamental distinction between signals and observables, or to use the academic terms, like behaviors and events. And so the reactivity umbrella in the academic literature encompasses these 2 different primitives with 2 very different sets of properties.
I want to pause for a second here and see if anyone has questions about the difference or the line that we would draw between RxJS and signals, or between observables and signals. Anybody have questions so far? And then maybe we can, okay, I just want to give some love to Tracy, because this was just such a great slide. So shout out to Tracy Lee for making that awesome slide, because that was great. And thank you, Ben, for helping her. That was such a great explanation of the difference. Okay, can you guys talk us through a little bit? I'm going to take the slide down. Can you guys just talk us through a little bit of like what the need for the signals proposal with TC39? Like, where did this come from? Where do you, like, I love it, don't get me wrong, but like, where did the decision come from that we needed to make this proposal?
Yeah. Oh, good.
I was just going to say, I don't know if it's so much of a need as it is the fact that every framework, with the exception of React, again, is landing on this exact same sort of thing. And the reason they would all land on this same sort of thing, and I have questions for Alex about this later, but hopefully we get time, is that, you know, if you have a signal, you can be like, hey, you need to update the view because something's changed, and you don't even have to tell it what's changed, where an observable is going to be like, here's this change, this change, this change, and like you'd have to act on it now. And then a framework can be like, oh, I'm going to wait until I'm ready, and then I'm going to get this value and render the view. in whatever means I choose to be good. Now, if you have Svelte and React or not React, we'll skip React. We'll say you have Svelte and Angular and Solid all in the same like micro front ends or whatever, like you might want to share state between these two things, all of these things. And if there's a native version of the signal, they could do so. But if there's not, then you're going to have some weird problems trying to talk between these things using signals.
So this proposal is not really necessarily creating something new. It's taking something that we have that everybody's been using and just making it more accessible so that everybody can use. So we're all getting everybody on the same page and just making it super easy for everyone to use signals.
Which is one of the reasons I think that we actually stand a good chance of standardization at TC39. They are very conservative as an organization, as they should be, right? They don't want to change JavaScript speculatively. And so one of the things they look for is, you shouldn't be trying to standardize something because you want people to use your new thing. You should be standardizing it because everyone's kind of already agreed that this is the right way to do things. And having, all of the frameworks with the exception of React saying like, hey, we want this to be a standard because we're all doing this independently and we see value in sharing is a powerful statement. So if you remember like Tracy's graph and what Ben was saying, signals kind of look very simple, but they have kind of more complex behavior under the hood. They're building this dependency graph between values. And one of the challenges you see with like having multiple frameworks on a page, and micro front end with Svelte and Angular and Solid, for example, they all have their own idea of what this dependency graph is because they all have their own implementation of signals. And so a signal in Solid means nothing in an Angular application. It doesn't participate in our dependency graph or vice versa. So the real value of sharing this concept, sharing the actual signal implementation, is sharing this dependency graph, participating in the same graph. So state maintained in one framework can be read in another, or even more generally, someone can write like TANSTAT query using standard signals, and it just works across all the frameworks because they all know how to understand its dependency graph.
Yeah, it also opens up an opportunity for browsers and others, because one thing that you need to understand is like the DOM is really like a framework for rendering stuff in a browser, right? Like, so you've got Angular and these other things that are a framework on top of a framework that happens to use JavaScript. If we have signals in JavaScript as a standardized thing, then you could or the W3C or the WhatWig or whatever has the opportunity to say, oh, we can use these types, and you could set an attribute to this signal, and then the browser itself can be like, oh, I've been notified this changed. I'm going to schedule a render. And all of a sudden you have the ability, their frameworks have the ability to take out a huge amount of the boilerplate that they might have and just be like, oh, well, I just wanted to update this DOM element, and it would just work. Now, whether or not that's actually going to happen, I don't know. Like that they're another conservative, less conservative, but slow moving entity that tries to build off of incremental changes over time. But it's certainly something I've heard discussed since this has come up, and it's certainly something I think would be very interesting to investigate.
Absolutely. What was your question for Alex?
Oh, my question for Alex, because he knows that I spent time in the Angular compiler, a tour of duty, if you will.
I still remember the frog eyes.
If as you're compiling and you see, oh, they've bound out a signal to this element, are you doing anything with your like frog eyes, whatever, like to be like, oh, this element here, we're just going to subscribe to notifications here and then schedule an update to that one element? Is it that targeted, or is it not that targeted yet? Is it just like try to render the whole component?
And as you answer this question, can you please let us in on the frog eyes?
Yeah,
I don't know this. I don't understand the frog eyes.
If you've ever looked at the Angular source code, you see our instructions have this like funny double Latin bar O prefix. which is a character that Mishko picked back in the day to like sort to the end of the auto completion list to like mark our APIs as private and get them out of your face. And at one point in time, Ben was trying to switch that symbol to another one we called Frog Eyes. It didn't go so well. That's a funny story we can get into later. But to answer the question, so today we talk about this as like, what is the granularity of updates? When something changes inside of a template, like which expressions do you run and then run change detection against to see like what DOM updates do I need to do? And today the granularity of update for signals in Angular is a component. We run the component and all of the embedded views within it. And the reason is because signals are mixed in with non-signals, with other Zone.js, or async pipe for RxJS even. And so we're kind of trying to find the thing that balances being able to start using signals, but not having to migrate your entire component to use signals, which would allow for more granular updates. So at some point, we will have a flavor of component that the RFC called signal components, which has that guarantee. Angular knows now that everything in that template must be changing through a signal. And that lets us play with the granularity of updating on a more finer basis than just doing the whole component. So out of the box, I think we're going to switch to doing what we call per view granularity. So that's like if you imagine a table with 1,000 rows rendered in a for loop, every row would be a separate update zone. So instead of doing the whole component and all 1,000 rows at once, you do each row individually as it changes with the signal. This is a trade-off between how much memory it takes to build this dependency graph and how much time it takes to update things when something changes. And so per view is kind of, we think, is a sweet spot there. Solid does it on a per element basis. So each element in Solid with all of the bindings inside that element update as one thing. Which is a bit more granular than view, less granular than individual expressions. And
I love having the Angular team involved in proposals like this, because we know that like going forward, and not just the Angular team, but like having everybody collaborating on this, because it's so much easier for us to follow where things are going when everyone's going in the same direction. It's really nice.
So when you talk about application performance, like there's weird trade-offs like Alex was saying. So the more granular you are, as he was saying, the more signals you'd end up with in memory, because every signal has something that in memory that's attached to it, and plus the dependency graph and that sort of thing. But the more granular the updates, the faster your renders will be. However, the more in memory you have, the more JavaScript you probably executed to get there, and the more like you're going to see garbage collection, like because the garbage collection runs in the same thread. You'll see that cause some shearing in your performance from time to time as the garbage collector does its business. But, in the happiest sense, if you had very granular updates and your graph wasn't that big, then you'd have a very, very, very fast application, because it's going to be almost what you would write if you were just doing plain DOM manipulation, just like update this thing, update this thing, update this thing. And like you wouldn't be trying to figure out if you need to update every element in a section or whatever. So
this is not an active project. This is not something we're like looking at doing. But one of our like crazier ideas, something that we're interested in researching and seeing if there's any like teeth here, is what if we could set this granularity slider inside of a component dynamically? So Angular could say, okay, we'll start off updating the whole view or the whole component at once, because maybe this thing renders and then like doesn't update ever again. And so there's no point in creating this like lots of memory usage to track individual expressions. But if we determine that like this is actually the stock ticker in your application and it's updating at 60 times a second, then Angular would like almost like a just-in-time compilation thing say, oh, let's dynamically adjust the granularity down so we start tracking individual expressions separately. We decide it's okay to pay the memory cost because the performance benefit is worth it for that part of the application. If we could do something like this automatically.
I love that.
It's a new idea. I don't think it's ever been tried before, but I think it's something we could potentially look into.
Render update inlining.
Yes, exactly.
Yeah.
So like the framework would detect that, oh, this is actually a hot update path, and we need to optimize that on the fly.
I think that would also help with, because one of the things that I saw quite a bit when I was doing enterprise consulting and all the training that I've done is that there are a lot of developers out there, and I was one of them, so I'm not judging. There are a lot of developers out there who don't really have a great understanding of the change detection cycle and how it works. And so they're just out there kind of and this is something that I talked about just a few days ago, that when you're putting a lot of business logic in your HTML, and Angular allows you to do that, but that's not scalable. I mean, it's this is the thing, your code will work, but if you, and I did the same thing when I first found Angular. I was like NG all the things. I was having so much fun. And so everything was NG this and NG that. And then when I moved it to production, it was really slow. And so this is the thing, is like, I think there's so many people that blame it on Angular, but it's really how you, like, if you it's same thing with RxJS. If you don't really understand RxJS, you can actually slow down your own code by accident because you're just using the wrong, things. And so, yeah, so I think I think that it might also kind of help with that, to have, like, if you have so much going on that all these things are dynamic that don't need to be, then maybe that would also be another thing, that the dynamic change detection, that's would really be helpful.
Right.
So
go ahead.
Oh, we talked. Yeah, go ahead, Ben. It's funny.
Sorry. I was just gonna say RxJS suffers from a completely different thing than what frameworks do, which is RxJS is asynchronous programming, and straight up, like, no matter how simplified you make, like, actually the simpler your asynchronous programming looks, the more likely there's a lot of bugs in it. Like, it's just not an easy thing. So anyone that's like, oh, I hate this RxJS stuff, it's like, well, okay, but you probably just hate asynchronous programming, and you're willing to write something where you feel better about it, but you probably just don't understand the bugs that are in it now. Like, I don't know.
I really thought I understood asynchronous,
set of problems,
but I didn't know anything about the event loop. I didn't understand how the event loop worked. And so I really felt like I understood it. And then I had an argument with Sonder, and I was so confident. I was wrong, obviously, but I was so confident about it because I really felt like I understood asynchronous and synchronous. And then it's like, yes, but if you don't know anything about the event loop, then it's really easy to be confused and not even know that you're confused.
Right. Well, just to get back on the signals thing, because I'm going to split here in just a second. The thing I was going to say is, like, reasoning about asynchronous programming is really hard, because synchronous programming, you read top to bottom, left to right, very deterministic. You know exactly what's going to happen when and whatever. Asynchronous programming, it's like a choose your own adventure where things go off and they do other things simultaneously while you're still reading top to bottom, left to right. And then they come back and they rejoin in whatever way you don't even know. There could be an error or whatever. And so here's the thing. Signals are much more deterministic, more like synchronous programming, where, like, they are something that are you can more likely read top to bottom, left to right. There you read from certain points, like there's the framework's taken all your ability to schedule away from you. Like, it's doing that stuff for you. Stay away from effects. Don't use those, because then you're into the same realm of, like, asynchronous programming issues and you're going to screw it up. Don't use effects. But, like, the signals where you got state and, like, your signal state, and you've got computed properties and you're binding them out to a view, very easy to reason about, top to bottom, left to right. There's your state management. Do not use RxJS for state management, because you're now at the mercies of asynchronous programming and having to have, like, the mental capacity to follow all that. And there's very few people in the world that are really, really good at being like, I see a concurrency bug as soon as they look at it, right? Like, and they're everywhere. Like, I could look at anybody's code base here, probably even the Angular code base, and be like, look, a concurrency bug, because they're literally everywhere in everyone's code, because asynchronous programming is hard. Most of the time you don't run into them because your users aren't the Flash. They can't click fast enough to make them happen. But, like, at the end of the day, they're there. Like, there's missing cancellation, or there's, some weird thing that could happen out of sync, but it just doesn't happen that often, kind of thing. Don't use RxJS for state management. Use signals. They're designed for it. They're much easier to reason about for state management. Similarly, don't use signals for events. It's bad. Like they're not for that. Like you don't need to maintain state for your events. So
yeah. Plus one to async programming being challenging. Like the way I think about it, Ben, is like RxJS is the worst tool for async programming, except for all of the other ones. Like,
right. Every now and then someone will come out of the library and be like, this is the new replacement for RxJS. And I just think, well, good luck.
No. Yeah. No, it really is like the Swiss Army knife. Like it's the tool you want if you have to go there, but the best thing to do is like try not to go there.
Right.
But Ben, thank you so much for joining us today. I know you have to go. We really love you. Before you go, everybody, can you come off mute and give Ben some love and help me thank him for making the time?
Thanks,
Ben.
Bye, Ben. Thank you, Ben.
Thanks, Ben.
We love you, Ben. See you soon.
Thank you, Ben.
Love y'all too. See you.
Cheers. Take care.
All right. Okay, Alex, did you want to share your screen and maybe kind of talk us through this proposal a little bit?
Sure, I am happy to. And I'll also share a link to my HackMD here if people want to.
Oh, we love this.
Lay along
when you
at
start,
home.
when you're gonna. This is my favorite part. Yes, please.
Yeah.
I love this.
So the standard signals proposal is a proposal to add a reactive graph and the primitives involved with working with it to the TC39 ECMAScript language that we all know and love. It is a collaboration between a number of different frameworks, and it's really designed at a kind of interesting level in the tech stack, I would say, where some parts of it are fairly user-facing. You can imagine using these APIs directly. Other parts of it are kind of designed for framework authors, designed to be integrated into an existing system. And the most obvious kind of sign of this is that the standard signals proposal has no effects. It has a lower level thing which you use to build effects for a particular framework, for a particular way of kind of reasoning about rendering. So I think that something that might be useful is, let's say, counter is a signal of 0. Like this is the Angular syntax for creating a signal that tracks what I would call like a writable signal, right? That tracks a number. And I'll show you the exact same in standard signal syntax, new signal.state of 0. So these two are effectively equivalent. This is Angular. This is the proposal for standardization. Now, the first thing you notice is it's a class. We're instantiating it, which is kind of weird, right? That's a bit more overhead. And this is kind of how the standard process works. Like you're not so concerned with offering the cleanest API. You're concerned with offering something that is a balance of a bunch of other things. So in Angular, you read this thing by calling it. In the standard proposal, you read this thing with a .get method. And one of the reasons for this is, with Angular, we don't expect anyone else to be taking our signal library and wrapping it or extending it, hopefully. We kind of don't like you extending Angular classes because they make it hard for us to do migrations and change your code. But standard signals are designed to be extended. So you can extend signal.state. You can override the get method and do your own thing. You can override the set method here and like call super.set if you want to. So it's designed to be an integration point where other frameworks can come and extend this thing, add their own behavior, adapt it to their own API shape if they want to. So as a result, you kind of the baseline thing gets a little bit more verbose, but it unlocks this power of being able to, in a performant way, wrap these things without having to create extra closures and stuff. So that is kind of the writable signal side of things, we also have computeds. So those in Angular, right, like double count, if I can type, as a computed of counter. We have the exact same mechanic in standard signals. So you can say const double count is new signal.computed, and you pass the same counter dot, or I keep calling it counter dot get. Exact same mechanic, just two different APIs for expressing it, with a very similar reason under the hood. Making this a class allows it to be extended, allows you to override the methods in a performant way, in a way the JavaScript engine can optimize really well. So really, that's signal and computed. That's the heart of a reactive graph. You can read this thing anywhere you want to. You can render it in templates. Everything should work just fine. Now, I mentioned there is no effect, right? So in Angular, I can say console.log of counter. And we all know that when the counter changes, when someone does counter.set to 5, then this thing will produce a log message, because the effect will run. But when does this effect run? Right? When is this actually executed? And the answer is it depends. It depends very much on the person who implemented the effect and what they chose for when they think this graph is in a consistent state where it's the right time to read it. In Angular, sometimes that is in a microtask. The main effects work in microtasks. We also have integrations with components. So you can, when you queue an effect inside of a component, the timing changes slightly because you have to wait for the component's inputs to be initialized in order to read all the input signals that you might want to wrap inside of your effect. That's not something we can very easily express in a standard. There is no one timing of when effects run that works for every framework across the board. Especially when you think of this is the user model for effect. This is the user function for effects in Angular. But there's also the effects that we get from just saying, I have a template that's going to read the counter. You think of it as an Angular component as a template, but it's actually a different kind of effect under the hood. And it runs with a very different timing. In particular, it has to run kind of after its parent component does. Because the parent component might say, I'm going to actually destroy this child. We don't want to show the counter anymore. So these things exist in a hierarchy that's determined by the framework's model of your application. So the standard actually has no effect operation. Instead, it has this thing that's a much lower level primitive called a watcher. And so you create a watcher, signal.watcher, and you pass something called the notify function here. Let's do it this way. And notify is a function that gets an instance of the watcher. So this will be the watcher that we did. And you can say for const s of this dot get pending. So signal s is dirty. And watchers don't do anything by default. You have to say watcher.add, and we add the counter to this thing. It's not add, sorry, it's watch. We debate the names of these APIs so much, you forget which one's the current one. Watcher.watch the counter, and that means that whenever the counter signal changes, the watcher will call its notify function and tell you that there's some set of signals that became dirty as a result of a write to the graph. Now, if you do something interesting in here and you say, okay, well, let me just console.log the value of the signal, or console.log the value of my counter even, let's say. These things throw. And they throw because we're not actually guaranteeing you that the graph is in a safe state to read these signals. Watcher is designed to tell a framework, hey, some things became dirty. You need to go and schedule execution of effects at some point. It's not safe to read it now, but you need to arrange for this thing to run in the future at the time that makes sense to your framework. So Angular would create the effect function. We can actually try and write it here. You have the effect, which is like the callback function that you want to run, let's say. And so we would write like watcher is new watcher. Let's get a notify function here. And then watcher dot watch. The inner. Let's put this up here. Queue microtask. This is a very poor implementation of an effect, but it gets the point across. So we create a computed around the effect function, which is an interesting thing. Every effect in the standard proposal is actually a computed under the hood. It's just like the reactive node in the graph. And then we create a watcher that's going to watch the computed we made. And whenever that computed gets marked dirty, so something sets the thing that's sets some signal that results in this thing needing to rerun, then in a microtask, we queue actually executing it. And so this gives us our timing. You can always think of effects as running some operation when a signal changes at a particular point in the future, when it makes sense to do that. And frameworks do that because they want to coalesce all of your DOM writing into an individual, like particular operation. You want to do all of your DOM writes before you let the browser go and paint the page. If you try to trickle DOM writes into the browser, then it's like constantly repainting and re-rendering, and that's slower. And then there's a lot else in the proposal that's kind of interesting. There's this subtle namespace under signal. This was a technique that
No batteries.
test. Hello. Yeah, my headset ran out of power. Yeah, I guess I forgot to plug it in last night. Anyway, yeah. So there was one of the things that the crypto proposal did was introduce this concept of a subtle namespace where you put stuff that like is not intended for all of the users, and has kind of interesting trade-offs. So that's where you find untracked, the same kind of operation we have in Angular. You can get a hold of what the current reactive context is. And there's these operations of actually inspecting the graph and understanding what are the dependencies of something, what are the dependents of something. Yeah, that's basically the proposal. So it's designed to kind of be this like lowest level layer of being able to express reactive nodes, sources, and computations, as well as utilities to build framework-like effect things on top of it.
Okay, Alex, I know you have a hard stop at the top of the hour, so we're going to have to wrap it up. I have a question, and I want to ask if anybody else has questions. This would be a good time to raise your hand and get those questions in before Alex has to go. So, Alex, it seems like everyone pretty much agrees on this signals proposal, which is mind-boggling that all these different frameworks and everyone's really chiming in about the signals proposal, and it seems like everyone's pretty agreeable about it. Do you see any, like, what is the next step? Do you think it's going to go through? Do you think it's going to be approved? How long will it take?
I think that we're on a timescale of years.
Just because that's normal for the TC39,
yeah, that's
right?
very normal for a proposal.
And
We
it's
have
just
a poly-
because there's so many people that have to like agree that anything that goes through TC39 is going to take a long time because they really don't, because this is JavaScript. Like they don't want to change things. So they're really conservative about any changes. And that's why it takes so long, but that's normal.
Yep.
But are
and
there
they
any
leave a lot of time for
obstacles?
discussion as well.
Yeah.
Are there? So the next, we're stage 1 in the process, which basically means like TC39 has accepted that this is something that they want to take seriously, which is a low bar. You just have to kind of show that you're like have your stuff together. The next step would be a stage 2 in the process, but getting there kind of requires clearing the technical hurdles from the TC39 team themselves. So this is where we prove that like this is something that is actually well designed to fit into the JavaScript standard. And they have raised some early concerns. You know, some of the members have told us like, oh, there's parts of the design, global state and things like that, or some of the designs of the classes that they would like to discuss in that sense. So I think like we'll have a lot of conversations over the next year or two. The spec will probably evolve away from what it is today. This is just the kind of like the first draft in that sense. And we talk about kind of, there's a lot of interesting innovation that's happening in Signals. And one of the things we're having to balance is how much do you try to standardize the minimum viable thing versus are you blocking off the ability to innovate on this thing by like standardizing it too early or not giving it the right set of capabilities? So
it's really hard to get a lot of people to agree on things like this.
Yeah, that's kind of one of the trade-offs that we have to make.
But it's also exciting because I mean we're talking about, you know, tech and programming and just like the bleeding edge when we're actually seeing technology advancing like right in front of us. It's amazing. It's kind of exciting.
Yeah.
I mean, if you're a nerd, which we are.
So one of the interesting exercises that we're doing is like every framework author is kind of porting their framework on top of the standard to prove that it can work. So Evan, you actually took the Vue reactivity library and ported it to standard Signals. Svelte has worked on taking their reactivity library and porting it to standard Signals. Angular, but the polyfill that we have is actually the Angular Signals core under the hood, which is a really interesting thing. So when Ben brought us into this conversation, because Dan was kind of, Dan and Rob were starting up this group and kind of reaching out to specific people in the ecosystem. Angular at the time was involved in a project with Wiz at Google to say, hey, let's see if we can share a Signals library. So we had already been working for a while to have a lot of these exact same conversations just between Angular and Wiz. How do you do effects? Your effects are different than our effects. How can we resolve this? What kind of tracking do we want? What kind of graph do we want? And as a result, we had built the Angular, there's a package, Angular core primitives signals. This is a runtime library that doesn't expose any end user APIs, but is the kind of backing library for signal computed in effect in Angular, that was designed as this point of sharing, where Wiz at Google, used in YouTube now, is using this exact same primitive library to build their flavor of signal computed in effect. And so when we got pulled into this conversation of, hey, is it possible to share signals between frameworks? We showed up and said, like, yes, we're doing it, right? We've built something that is a common ground. And it ended up being a really useful, set of code when it came time to actually build a polyfill to base it on this implementation.
That's beautiful. So when the signals, so if and when the signals proposal is actually approved and becomes JavaScript, you guys will already be like,
yeah, there'll be some porting work, right, to kind of because it's our library, we're kind of able to integrate more deeply with it. We'll have to kind of unwrap some things, but it should be a relatively straightforward translation to be on top of that standard.
Nice. Okay, we're almost at the top of the hour. Any closing thoughts? Anything that we can do? Oh, wait, hold on. We got a couple hands going up. Do you have time for a couple of quick questions?
Yeah, of course.
All right. Let's see. I don't know whose hand went up first. Abraham.
Yeah, a short question. You said that the TCN organization said that they have some concerns related to this.
Yeah,
related to this proposal. So, like, could you maybe tell us some of the concerns? Because this looks good, but I don't know.
Yeah, absolutely. So let me just go and grab the see if I can just pull up the list that they gave us. Might involve quite a bit of scrolling back. So some of the concerns that they brought up, and these are not like blocking issues in the sense that they are things that they're demanding be fixed. They're saying these are areas where we could see problems and we want to talk about it. One of them is the kind of exposure to global state. So having the ability to read the current computed. This is essentially a global variable that every single library has. And they're concerned that it's okay to have global variables, but it's weird to directly expose the fact that there's global state. That's one thing they want to talk about. They want to talk about the use of classes and the performance trade-offs of that. They want to talk about the restrictions around reading signals during the notify phase. That's again kind of a visible global state piece that's in there. So kind of technical points on when you integrate this in with the rest of JavaScript. Another one was, if you remember what I said, that effects are kind of a signal plus an event, right? It's like an event at a particular time telling you when a signal changes. One of their concerns was, hey, JavaScript is really kind of in a weird place right now where we don't have a standard event primitive. The observable standard from the web working group, the WG, that is one attempt to solve this problem. There's event target. There's a few other mechanisms in JavaScript for raising events, and this looks like it's introducing another one. So should we be using a different, and are we able to reuse an existing standard rather than add another bespoke callback operation? So it's things like that where they're looking not just at the proposal itself, but how the proposal fits into JavaScript as a whole. It's actually I have a lot of respect for that process. It's really seems well driven with the right set of goals in mind.
Nice question, Abraham.
Yeah.
All right, Pavel, we're gonna make Pavel the last question today. What you got, Pavel?
I have two questions in a row.
Okay.
Oh,
sorry. I know, but I would love to know the answer for the second question as well.
Yeah, go for it.
Anyway, the first of all, because I have been noticing the things that on the signals they are basically ongoing so much features. For example, signal components, form with signals, and so other stuff like that. First of all, is there going to be some migrating tool for the developers in the future for it? Or there are some plans for it? Because I can imagine that when we are going all signals mode without a zone, then it's going to be a huge refactor for the applications, which are basically based on the zone. So that's the first question.
Ooh, yeah, that's interesting. So I'll try to be really fast. In V18, you will see something land in Angular called hybrid mode, which is where we start using notifications of mark for check or a signal to run change detection even without zones.
We got a really cool article from Matthew about that.
Yes, yeah. And then there's the experimental zoneless kind of option that you can start using. There is a flavor of zoneless. There's a way to use zoneless where you do not touch signals. If your root component in your application is on push and your application still works, it is very likely that it will at least mostly function under zoneless. Because you're calling mark for check, you're telling Angular that it needs to check on push components, and we can use that exact same callback, that exact same information to make it run change detection without zones. There's a big asterisk there, which is you also have to not be using other zone patterns like ng-zone on stable or like any of the ng-zone APIs really. Any of the other features of Zone.js. But largely it should be like a smaller target to move from on push to zoneless. You mentioned migration. It is not really possible to migrate an application from not signals to signals, or from not on push to on push. But we can't do it perfectly because it's a mental model shift. What we can do is try to make the mechanical part of that migration easier for you. So where you might have to rethink or kind of think about how the state is going to flow, but at least we can do the work of converting variables to signals or inputs to signal inputs or queries to signal queries. And then you deal with kind of the fallout of what that means semantically for your application. I think Enia has some of those migrations in the ng extensions. And we're looking at, as we get closer to signal components, do we want to adopt those as mainline ng update migrations?
Okay. Fair enough. Yeah, thanks. And
I'm so sad because we're out of time. This was so much, Alex, we love it when you come by, and I'm so sad that you have other work to do besides hanging out with us all day long.
I know.
But I do want to respect your time and wrap this up. Before we let you go, we have a tradition here. Can everybody please come off mute and help me thank Alex for making time and teaching us cool stuff?
Thank you.
Thank you.
Thank you, Alex.
Cheers.
All right, I'm going to turn off the recording. Everybody feel
Yeah.
free to stay and hang out. And thanks again.
Cheers.